Hello everyone, in this video I'll be solving a 3x3 matrix, and this is the 3x3 matrix that I have at hand. So 3x plus 4y plus 6z is equal to 40, 1 over 2x plus 2 over 3z is equal to 30, x plus 3 over 5y is equal to 10. Now I need to express this in matrix form. So my matrix is going to look something like this. So this is my matrix, and then what comes on this matrix, let me just create the whole matrix. So what comes here on the first column are the coefficients of x. So the coefficients of x that I have there are 3, 1 over 2, and 1. So these are the coefficients of x. Now for the coefficients of y, you need to be careful, because for the first equation, the coefficient of y is 4. But then if you look at the second equation, there is no y. So this is going to be 0. And then for the third equation, I have 3 over 5 as the value of y. Similarly, if I go to the first equation, z is 6. And for the second equation, z is 2 over 3. And for the third equation, there is no value of z. So z is 0. Now, what I have on this column vector, as they call it in mathematics, are the variables. So for the first column, I have x. For the second column, I have y. For the third column, I have z. And then here, the solutions are 40, 30, and 10. Now, this is how you express your system of equations in matrix form. Now, how do you then get the determinant of this matrix? Well, the determinant of this matrix is, we get it in this manner here. So these 3 on the first column, the first value of the first column is going to be our factor. So delta is equal to 3, so this 3 is going to be our factor, and then you're going to multiply by the minus of this. So what is this thing they call minor? So where your 3 is, so you eliminate the column and you eliminate the row associated with 3. So now what do you see? You see these 4 entries here. So you just need to do determinant, just like a 2 by 2. So you just multiply the leading diagonal minus the outside diagonal. So what do you get? So 0 minus 2 over 3 times 3 over 5. I hope you can see that. So that's the first value of your determinant. For this, we are going to have 3 values. Why will I have 3 values? Because this y will also be my factor, and this 6 will also be my factor. So it's going to be, and by the way, this is plus, minus, plus. So don't forget this. And I believe in statics, you did something like this. So these 3, if this was statics, this would be your I, J, and K. But then our I, J, and K here are 3, 4, and 6. Okay, so let's continue. So for the second one, for the second factor, I have negative 4. I hope you can see. So it's negative and it's 4. So that's my factor. And then I open it, and then I eliminate the column associated with 4 and the row associated with 4. So what do I get when I eliminate the column and the row? You can see I've got 1 over 2 times 0 minus, so this is the leading diagonal, so 1 over 2 times 0 minus 2 over 3 times 1. So I have 1 over 2 times 0 minus 2 over 3 times 1. So this is my second solution. Now my third solution will come when this 6 here is a factor and it's positive 6. So then I'll have positive 6. I hope I can just write it here. So positive 6, open brackets, and then I eliminate the column and row associated with 6. So when you do this, what do you get? 1 over 2 times 3 over 5 minus 0 times 1. So I have 1 over 2 times 3 over 5 minus 1 times 0. Now if you calculate this, you're going to get the determinant of this matrix. So let me just use my calculator to see what the determinant is going to be. So I have 3 negative 2 over 3 times 3 over 5 minus 4, and then this is 0, minus 2 over 3 times 1 plus 6, 1 over 2 times 3 over 5, and then the last one is 0. So my determinant is 49 over 15. So this is my determinant. So 49 over 15. I would recommend you to write it as a fraction so that you don't round off all the way. So you can just write your determinant as a fraction and then the determinant of whatever they're asking you for. And for this example, I'm planning to find the determinant of z. So what is going to be then the determinant of z? So the determinant of z, if I show you, z, the coefficients of z are on the third column. So I'll substitute the values of these coefficients with the solution. So then I'll have something like this. So 3, 1 over 2, 1, 4, 0, 3 over 5, and then I'll substitute the values here. So I have 40, 30 with the solution, and this is determinant, which is given by this symbol here to represent the magnitude of the determinant. So this is delta z. So this is my delta z. So I just do the same thing again. So I take 3 as my factor. So I have 3 times, and then I'm going to cancel these 2 associated with the 3. So the row associated with 3 and the column associated with 3. So I'm going to cancel them. So I have 0 times 10, which is 0, 30 minus 30 times 3 over 5. And then remember, this is plus minus plus minus. So this is plus minus plus, like that. So the next one is going to be negative 4. So I have negative 4. And then I do the same thing. So the column associated with 4 and the row associated with 4. So now I have 1 over 2 times 10 minus 3 times 1. So I have 1 over 2 times 10 minus 30 times 1. Then for the third one, it's positive 40. And then I'm going to cancel out this column and that row associated with 40. So now I'm left with 1 over 2 times 3 over 5 minus, that's 0. So it's 1 over 2 times 3 over 5 minus 0. So you just take your calculator. No need to use mental mathematics here. 3 over 5 minus 4, 1 over 2 times 10 minus 30 plus 40, 1 over 2 times 3 over 5 If you do that, you're going to get 58 as your answer. So delta Z is equal to 58. So just like in 2 by 2 matrices, after you get your delta Z and then you get your delta, so Z, the value of Z is going to be delta Z divided by delta. Delta Z, we found it as 58. The value of delta was 49/15. So Z, using my calculator, is going to give me 58 divided by 49/15. And then my solution is, now I can write it as in decimal notation. So 17.755. Let me just write it like that. So this is my value of Z, and this is how you solve. So for the X value, you just do the same thing. For the Y value, you do the same thing. Thank you.